Hey everybody, we are working on our first problem in probability, and we are going to be doing a sensitivity, specificity, uh, positive predicted value kind of problem, one where we're looking at how effective is the test. Um, so let's look at it. The sensitivity of a rapid flu test is approximately 60%, while the specificity of the test is around 95%. Approximately 10% of people got the flu in 2024. What is the positive predicted value, or the PPV, for the flu test in 2024? You can use the tree diagram method, you can use those basic probability rules and just some logic, or you can use Bayes' theorem to solve this problem. Any of these methods should get the same answer. I'm going to use Bayes' theorem, so if you use a different method, you should get the same answer I do. So just a quick reminder, PPV is the chance, the percent or probability of having the flu for real if you tested positive. And so that's actually the probability we're looking for. So PPV, or our positive predictive value, is the probability of actually having the flu given, and remember that vertical line means given, that you tested positive to the test, to the flu test. So I'm going to use flu and no flu for someone who actually has the flu or doesn't have the flu. I'm going to use a plus and a minus for whether you tested positive or negative to the test. And then this vertical line here, remember, I'm going to change colors here real quick. This vertical line means given. It is a conditional probability. So when we use Bayes' theorem, the probability of flu given a positive test result is the probability of having the flu times the probability that we tested positive given that we actually have the flu, divided by that exact same thing. So the probability of having the flu times the probability of positive test result given that we have the flu, plus the probability of not having the flu, so no flu, times the probability of having a positive test result given that you do not have the flu, or no flu. Okay, so remember we built Bayes' theorem through examples in the notes. And so for me to answer this question, I'm going to need the probability of flu, the probability of positive test given that you have the flu, and the probability of a positive test given that you have no flu. The rest of the stuff I can find out from complements. So let's skip a little space and we'll write down what we know. And I'm going to change colors here, so what we know. So remember, sensitivity was 60%. And sensitivity is the probability of a positive test result given that you actually have the disease. So in this case, it's the probability of a positive test result given that you have the flu. 60% of the time, that's true. And so we're going to get the complement of that. We might or might not need it. We'll look in a minute. So that is the probability of having a negative test result given that you have the flu. That's 0.40. Then specificity, and I'm going to skip a little space here because I'm going to keep it in the same order as the notes. Specificity is the probability of getting a negative test result when you do not have the flu. So there's no flu. And if we look back up in this problem, the specificity is about 95%. So that's 0.95. And so I'm going to keep my positive and negative tests in the same order. So the probability of a positive test when you have no flu, this is what I said about keeping it the same in the notes, is just the complement of a negative test when you have no flu. So 1 minus 0.95 is 0.05. And so now there's one more thing we're going to need to solve this problem, and that's the probability of having the flu, which was given to us. That's the 10%. So the probability of having the flu is 10% or 0.10. And we can go ahead and do the complement of that. We're not going to need it. Probability of no flu is 0.90, but in case you're doing one of the other methods, you may need it. Okay, so we can use these numbers to plug them into Bayes' theorem. So I'm going to go back to the pink. So the probability of having the flu is 10% times the probability of a positive test result given that you have the flu is 60%. Remember, this is sensitivity. So sensitivity is 60%, so 0.60, divided by, we keep that same thing in the denominator, 0.10 times 0.60, plus the other possible options. So the probability of not having the flu, is 90%. So we do actually need that number. It's right there. So 0.90 times the probability of a positive result given that you do not have flu. A positive result given that you do not have flu is 0.05. So the numbers we needed were the sensitivity, the complement for the specificity, and the chance of having the flu and the chance of not having the flu. Plug all that into your calculator. Please remember that the denominator is in parentheses. So plug all that into your calculator and you should get 0.57. So what that means is 57% of folks who tested positive actually had the flu. That means that a whole bunch of people who had the flu, so a whole bunch of people who tested positive didn't have the flu. Okay, so that's it, you guys, for this lesson.